Well, you've probably thought to yourself someday, well, how did the stars in the night sky get there? Or how are they formed? Well, I assure you that each and every one of these stars have got an amazing story to tell. This is the life cycle of a main sequence star. Well, just for some reference, in our Milky Way, there are 100 billion stars. And for more reference, in the observable universe, there are 100 billion trillion stars. Yes, that is right, that number is big. Well, the journey of a young star begins in a stellar nebula. Basically, a stellar nebula is a massive cloud of gas that forms new stars. Well, an example of a stellar nebula is helix. Inside a stellar nebula, you'll find cosmic dust, hydrogen, helium, and space plasma, all the ingredients needed to form a new star. Well, all of these elements will form into these blobs as shown in this image, which they will form a new star. This is a real-life image taken by the James Webb Space Telescope of the creation of a new star. In case you did not know, the James Webb Space Telescope, or JWST, is the world's most advanced space telescope. If this stage goes well and all of the elements mix, the star will move on to the next stage, the massive star. The star will evolve into a massive star. It is basically a star which has got 8 to 100 times the mass of the sun's. Well, basically, an example of a massive star is Arcturus. Arcturus has got a mass of 1.1 solar masses and has got a diameter that's 26 times greater than the sun's. Well, moving on to the next stage, the red or blue supergiant star. After a few 100,000 years as a massive star, the star will evolve onto a red or blue supergiant star. These are massive and monstrous. These stars have a mass that's mainly on average around 1,500 times greater than our sun's. The largest supergiant known to man right now is Stephenson 218. Because this star is so big, its mass is unknown, but it does have a diameter of 1.4958 billion kilometers. Stephenson 218 is right now the biggest star in our universe. After 30 million years as a supergiant star, the star will move on to a supernova. After that, the star finishes fusing hydrogen into helium. The star will start fusing iron, but this is very bad for the core because it will just collapse on its own weight. I'll explain why. Well, you see, because the core gives out all of that heat and pressure to support the gravity. But if that disappears, the star will implode and explode, leaving behind a beautiful sight in our night sky. Even after this, it's not the end of the line for our star. If it had 15 solar masses or more, it would turn into a black hole. These things are absolutely monstrous. They consume everything in its way, from planets, even suns as big as Stephenson 218. The gravity of these things is so immense that not even light can escape it. Well, that's all from me. Thank you for watching. To the next one.